Okay, here we have our last topic for HTTP. Its name is Conditional Get. We introduced several different mechanisms on the top of HTTP, for example, cache, for example, cookie. And all those things are used to enhance the capability of stateless HTTP to enhance your performance while you retrieve objects from web servers. And conditional get is also an enhancement of HTTP. It can also help the client to retrieve the objects more quickly from the server. Okay, so here it is. Left hand side is client, right hand side is server. When client send an HTTP request message to the server to request for a certain object, the client can add one additional header, which is called if modified things. And here is a date. Okay, that means the client might have already retrieved the object maybe 1 day ago, 2 days ago. But currently the client wants to retrieve this object again, but it sends the request with a specific header if modified since a date. That means after the server parse such kind of request with the header, and the server will check the date right here, okay, and to see if the object is modified or not modified after that specific date specified in this if modified since header. Okay, so if the object is not modified, okay, if it is not, then the server can simply just reply a very simple response with a status line that 304 not modified, and that's it. No further object or message will be transmitted from the server to the client. That's it. Only a very small header response message with a very simple header 304 not modified, so that the client can, after the client get this response message, the client don't have to the client and the server don't have to transmit the object again. The client can display the object by using its local cache. So there should be a local cache. It is a little bit different from the proxy server that we introduced last week. The local hash here is just a temporary folder in the client host, and as you know, your browser will save all the retrieved object in its local cache. It is a temporary folder, so the client can find the not modified object from its local cache, so that they don't have to transmit through the entire internet again. So that is more convenient for the client, and it can save certain bandwidth, right? So what if the object is modified after that date? Then again, the server will send HTTP 200 OK, and of course the data, the new object, will be carried in the response messages. So I think that is a very elegant and simple mechanism, but the client can benefit from such kind of mechanism. They don't have to waste the bandwidth, waste the memory, to waste the time to transmit the exactly the same object. So let's take a look at this text. Don't send object if cache has up-to-date cached version, no object transmission delay. So there's no need to use network resources. Okay, so that is the last mechanism that we cover in the HTTP section, and I think that's it. That is of the HTTP protocol we introduced here. And as you can see that I put some slide about HTTP 2, which is a new version of HTTP protocol, but we will not go over all this HTTP 2 slides right here. So if you're interested in these things, take a look at textbook and HTTP 2. Maybe we will go over all those new protocols maybe next year or next year, because it is relatively too new to students. So and I think most of the servers right now, they still use HTTP 1.1. So we simply just give you some materials, and if you're interested in these things, you can take a look at this vgraph. Okay, next is the second protocol we'd like to introduce. That is an email protocol. So right here, so basically deliver an email from the sender to the receiver is quite different from exchange objects between HTTP client and HTTP server. The reason is that when you send an email, okay, you cannot expect the receiver, the email receiver, is online, right? Because you, for example, you have an email address, right? But maybe you turned off your PC, you turned off your smartphone, your tablet. So basically, you're not online. So since you're not online, there is no two remote process that can communicate with each other directly, right? Because some of the process is not online, the socket is not open. So email has another mechanism to deliver email. Okay, so the first thing we'd like to introduce is UA, user agent. You have to, it's right here. Okay, you have to install some programs, applications in your PC or in your mobile phone to receive or send message. That is called UA, user agent, or as known as email reader. Okay, to compose, editing, reading email messages. But however, just as what I mentioned in HTTP browser, the HTTP protocol itself is to define the format, the actions, the syntax, the semantic when the HTTP client and HTTP server exchange the messages, right? So display object on the screen, that is not defined in the HTTP protocol. It's the same right here. Composing, editing, reading is not the main purpose of the user agent. Of course, it is the main purpose of user agent, but it is not the main purpose of email protocol. The email protocol itself defines the email messages format, how do they exchange email messages, what is the format, what is semantic, what is the syntax of email message itself. It does not, it really doesn't matter how a user agent to show a window to for you to compose, to edit, or to read the emails. Okay, and of course there are some well-known user agent, for example Microsoft Outlook or the iPhone email client, or if you use Thunderbird, maybe you use you know there's another email agent, okay, open source email agent. Okay, that's it. Okay, so the protocol that we would like to introduce right here is Simple Mail Transfer Protocol, SMTP. Okay, right here there are several different roles involved in such kind of mail delivering. Okay, so thing right here. Okay, for every user right here. Okay, the red circles. For those users, okay, no matter they use PC or you use cell phone, they have to install a user agent, and of course, those user agent knows how to transmit or receive messages of SMTP. Okay, and there are some email servers right here. Okay, so you have to think about one thing. I think it's right here. Right. Okay. You have to think about one thing. Since you cannot directly, okay, I can draw it. Since you cannot, okay, you cannot directly send your email from your user agent to the receiver's user agent because it may not be online. So we have another role, which is the email server right here. So for you, for example, I have an email. Let's take a look at this one. Okay. For example, if you have an email address like Alice at email.com, okay, so there should be a corresponding email server that support your delivery. So there should be an email server right here. Okay, so it is email.com. Okay, for example, you would like to send an email to Bob at school.edu, for example, and it has a corresponding email server, okay, which is school.edu, something like that. Okay, it's very similar to deliver a mail, but when you deliver your physical mail, you have to write your mail, right? So that's you are the user agent. You have to write the message, right? So the message will be passed from your user agent to your email server. It's simply like you go to your neighboring post office and you send your email. You send your mail and give it to the post office, which is near to you. Okay, after that, your email server, okay, will deliver this specific mail from your local mail server or post office to the receiver's post office or to the receiver's email server. Okay, so they will initiate a SMTP connection and send the email message from your local email server to the receiver's email server. But the email will be queued. It's right here. The email will be queued at the receiver's email server. So it's like a mailbox, okay, like a mailbox. But the email server, the receiver's email server, will not deliver this email to the user agent, to the receiver's user agent, because they don't know if the user agent is online or not online. Okay, so for Bob right here, for the Bob, okay, Bob will have would have a mailbox right here, Bob's mailbox, and the mail will be queued at Bob's mailbox. Okay, so after when Bob is online, when Bob's user agent is online, okay, the Bob's user agent will create a new socket and connect it to its mail server to retrieve the mail queued in Bob's mailbox and get we use the word pull, okay, and they will pull the message back to user's agent, and that's it. That is how mail is delivered from your user agent to your mail server, and then your mail server will contact to receiver's mail server and queue the mail in the corresponding mailbox, and Bob will pull the mail from its own mail server. So that's it. That is the entire communication between how those mail message will be delivered. Okay. So the protocol that we used right here is SMTP, and you have to think. You have to remember one thing is that I think that's we'll talk about later. Okay, but I want to mention it right here. Okay. When you're as a sender, when you push your mail to your mail server, the protocol you use right here is SMTP. Okay, and when those two mail servers they communicate with each other, they still use SMTP to push mail from your mail server to the receiver's mail server. Okay. However, when they do pull, the protocol right here is not SMTP. We'll talk about later. Okay, it's not. Okay, but you have to remember this. Okay, and there's a very strange things right here. Although your email server, okay, its name is a server. Usually a server should serve a user agent, but it's very similar to the web proxy server. Okay, sometimes the mail server acts as a mail server so that it can serve you, but sometimes its role changes to a client, because at that time the receiver's mail server will serve your sender's mail server. Okay, so sometimes it acts as a server to serve your user agent, but sometimes it acts as a client to be served by the receiver's mail server. So it's very similar to the HTTP web proxy. Okay. So here is the RFC. Its RFC number is 5321. Okay. Again, since we were trying to send email, right? So every bit should be exactly the same as what you send to the socket. So SMTP use TCP for the reliable data transfer, and its port number is 25. Okay, it's 25. So let's take a look at this scenario. Okay, make sure that is sender's SMTP server, that is receiver's SMTP server. Also, let's take a look how those email servers communicate with each other. Okay, since all those servers are always on server, so they will be online. So we can simply just contact with the remote email server. Okay, so there are three phases right here. Okay, the first after of course right here. Of course, since the SMTP use TCP, so they have to establish a TCP connection. So it need to spend an RTT to establish the TCP connection. Okay, after that, those two layer 7 application layer protocols, they try to communicate with each other. Okay, so very first one is that oh, sorry, the line should be right here. Okay, after they establish the TCP connection, okay, the server will propose. Okay, the server will have a banner. Okay, the banner is 220. Okay, basically that is the SMTP handshaking. That is a greeting words. Okay, that's the greeting words. Okay, so the greeting words is right here. Okay, we will talk about the actual message exchange in the later pages. Okay, you have to know that they have to do some handshaking to exchange the parameters, the informations about this server and the sender's server and the receiver's server. Okay, what kind of message they can exchange, what kind of encoding they use, where the mail will be sent to, some information like that. Okay, so that is the greeting handshaking. Okay, and for the second part, it's the email itself. So the first email, including its title, including its subject, including the time, including the message itself. So that is the transfer for messages. And after that, of course, okay, there will be SMTP closure. Okay, so two servers will say goodbye to each other, and they will terminate this TCP connection like that. Okay, SMTP is very similar to HTTP. They both use text-based, which is an ASCII text, to communicate with each other. As I mentioned before, because it is a very old protocol, at that time people usually use text-based protocols rather than use a binary-based protocol. Okay, so and again, they have status code, they have phrase, so both of the communication peers, they know how to act to the received messages. Okay, so again, okay, we have okay, we have 6 steps right here. So that is Alice. Okay, that is Alice. For example, some school. Okay, email. Alice at email.com. Okay, so that is Alice agent. So Alice's corresponding email server should be email.com. Okay, and Bob's email address is bob at some school.edu, right? So its corresponding email server is some school.edu. Okay, and there's a mailbox for Bob. Okay, and of course there's a mailbox for Alice. Okay, so the first step is Alice uses her UA, okay, to compose a message. So the UA knows how to create a SMTP protocol message. Okay, so there will be a message right here. Of course, it will be encapsulated by TCP and transmit through the internet and goes to Alice mail server, email.com. Okay, so the second step is Alice UA send a message to her email server using SMTP. So right here, that is SMTP. Okay, the message that it uses is SMTP. Okay, so the message will go to Alice's mailbox and go into a queue because it is waited to be pushed to the next email server, which is the receiver's email server. Okay, so now Alice's server now acts as a client of SMTP and open another new TCP connection to the receiver's email server. Okay, and the message will be pushed to Bob's mailbox. Okay, so that is step number 3. Alice server acts as a client and open a TCP connection and send the message through the TCP connection 3 and 4. Okay, so number 5, Bob's email server placed the message box in Bob's mailbox is right here. Okay, and that's it. That is all about SMTP. The message will be queued in Bob's mailbox, and that's it. That's it. Okay, so after maybe 1 hour later, 2 days later, for any time, that when Bob's agent goes online, okay, they will use another layer 7 application layer protocol to retrieve this mail back to Bob's user agent. So that is, Bob invoked his user agent to read the message, to retrieve the message and read the message at its own PC or its own smartphone. But you have to notice that that is not SMTP. Okay? So here is some simplified SMTP interaction between 2 email servers. Okay, so that is sender, again, that is sender's SMTP server. Okay, that is receiver's SMTP server. Okay, so let's take a look at the exact messages that are exchanged between these 2 servers. Okay, so the green one is the client and the blue one is the server. Okay, so before that we have TCP establishment. Okay, so after that we have TCP termination. Okay, so we simply just don't show any TCP information right here. So, but you have to know that before you send the SMTP message, you have to establish the TCP connections, and after you finish sending SMTP messages, you have to close your TCP connection. Okay. So, first things, okay, the blue one. Okay. The first message is sent by the server. Receiver server. Okay, so that is a little bit different. That the server talk first. We in HTTP we usually say that a client is the one who talk first, right? Usually we say that, but in SMTP, server, which is the receiver server, talks first. Okay, so the messages are all text-based. So you can see that the first message from the server to the receivers from server to client to SMTP client is 220 hamburger.etu. So there is a white space right here, and that is the enter right here. You have to notice that when we say client right here, that means currently sender's SMTP server now acts as a client when the sender's SMTP server push the mail from its mailbox to the receiver's mailbox. Now the sender's SMTP server acts as a client. So we use the word client right here. Okay, so the first message sent from the server is 220. That means, hello, I am hamburger.edu. And the client, which is your sender's SMTP server, says, okay, hello, I am crypt.fr. And of course, there is a enter right here, okay? And you can see that unlike HTTP has only one request message and one response message, but SMTP relatively more like an interactive protocol. They will exchange lots of, right here, they will send a lot of message between the client and the server. Okay, so basically these two messages, they are greeting messages. Okay, and again, server says 250, hello, someone, I'm pleased to meet you. The client says, okay, I'll send an email from Alice, blah blah blah. Now the server says, okay, I will receive a message from you, from your user Alice, and the receipt is your user, which is Bob. Okay, and so on so forth, so on so forth, so on so forth. Okay, so there are some keywords so that you know what the client wants to do. And of course, there are some response code right here, so you know everything is still on track. Okay, so 220 means okay, 250 is okay. Okay, so I think the important things you have to notice is that after they exchange, okay, it's right here, after they have exchanged the sender's information and the receiver's information, they will further send the email, send the content. Okay, so the client send a specific message, data, to the server, and server knows, okay, the client will trying to send the email. Okay, so the server says 354, so it says, please enter the email, and I will receive a bunch of line, and I expect to receive a bunch of line of emails. And after that, when you finish sending your email, okay, please, okay, send me a single dot on a line by itself. Okay, so right here, actually this part, okay, it is a very simplified example, but it has only 2 lines, but you can send an email with maybe hundreds of lines, thousands of lines. Okay, but that specific dot right here, it specifies, okay, that is the end of this email. Okay, so after that, the server says, okay, 250, message accepted for delivery, and client said, okay, quit, QUIT, and server says goodbye, closing the connection. And after that, you can close the TCP connection. Okay, so that is a very simplified example, but it did demonstrate how they greet with each other, greeting. They do greeting, and they exchange the information about the receipt to, or the mail from. Okay, right here, mail from, and receipt to, and the data and the termination. Okay, so since we have now we introduced 2 different protocols. Now we say that for HTTP protocol, okay, client pull the object, the resources from the server to the client, right? However, to deliver an email, the SMTP client will push those email message from its user agent to the remote email server, right? So it's a little bit different, okay, about pushing and pulling. Okay, but they both have ASCII command and response interaction status code, so we can easily understand what's going on right now from the perspective of human beings. Okay, so for HTTP, each object encapsulates in its own response message, right? But SMTP has a very specific structure. Okay, as you can see right here, this part. Although this oversimplified example only demonstrates that it has only 2 lines and 1 dot specifying the end of the email. But however, if you'd like to send an email with, for example, a file an attachment, okay, the attachment will be included within this specific block. Okay, we will show you how to include several different images, files, or HTML files in a single email, in this part, in a single message right here, single block. Okay, single block right here. But for HTTP, right, each response message has only 1 encapsulate object, right? Okay, so we'll talk about this later. Okay, so right hand side, SMTP use persistent sys connection, so they simply just use 1 TCP connection to exchange, every line right here is a message delivered from, no matter from client to server or server to client. Okay, SMTP require messages header and body to be in 7-bit ASCII encoding. Okay, so again, like HTTP, they don't support any other language. Only ASCII characters can be used in SMTP protocol. So if you want to you would like to write the email in, for example, in Chinese, okay, you may want to use UTF-X. You may want to use UTF-8 to encode your Chinese character. But of course, there are some other functions that can help you to I say encode, okay? Encode your UTF-8 characters to ASCII representation. So that is very important. We will show you it later, okay? So, and again, SMTP server use CRLF, which is right, to terminate the end of the to determine end of messages. Okay, so that is okay, and of course there's a specific format need to specify to send a mail message. Okay, SMTP has a specific RFC, which is right here. Okay, this RFC 5321, they defined the format, the exchange behavior for the client and server. It's right, it defines right here. However, here, the messages that you send in SMTP, basically, there's another RFC, which is RFC 2822. They define the syntax, okay, for the email message itself. Okay, so right here, something like that. They have a specific RFC to define the message, okay, the message format. Okay, so right here, so the purple block right here is exactly what I I draw right here. Okay. Okay. So let's take a look. Usually there are several different, of course, headers that you should specify in your your mail message format. Okay, and again, it can be divided into two parts. Okay, the first part is still the header. The header should specify where the message from and where the message goes to. Okay, and including the subjects. Okay, those lines within the body of the email message. Okay, very important thing is that the to header in the RFC 2822 is different from where is this? Right here. It's different from RFC 5321 mail from and receive to, because they are defined in different RFC. So basically, you can say that, okay, in RFC 5321, and when the server and the client they communicate with each other, okay, the client says, I have an email from Alice. It's right here, right, from Alice. Okay, so the server, the hamburger.edu, knows that is from Alice and it will goes to Bob. But after they do such kind of communication, remember that only the mail itself, okay, only the mail itself will be stored in the mailbox. So apparently all those control messages exchanged between the server and client will not be recorded in the mailbox. Only the mail itself, RFC 2822, will be saved in the mailbox. Okay, so for RFC 2822, they still have to record some information about where the message from and and where the message should go to. Okay, so these two are two different things. Okay, make sure you understand that. So for some hackers, okay, for some hackers, when they deliver message from their malicious SMTP server, okay, they will forge, or they will set fake mail from and receive to in RFC 5321 when they communicate with the receiver's SMTP server. Okay, however, the messages inside RFC 2822, there's still a from and to, right? They will maybe these four values are not aligned with. They may have different values. So when you receive your email, the mail, where this mail from, you can only see the mail from in RFC 2822. You will not see the mail from RFC 5321, because this control message is right here, or these control messages they will not be stored at the receiver's SMTP. That's simply just some command line exchange between the client and server, and they will disappear after the communication. Only this RFC 2822 will be stored in your mailbox, and and if it says, okay, it comes from White House, and in your UA, your user agent, it will show it comes from White House. However, maybe it's not. Because usually the mail server right here, the receiver's mail SMTP server, they will not check any information in RFC 2822, right? So that is okay. So make sure you understand the RFC 2822 and 5321. They are different. Okay. So okay, I think that is this one. Okay, we have 5 more minutes. I would like to show you. Okay, let's take a look at the last page, and we will show you how email are delivered in real life. Okay, so the last page is that when you retrieve, okay, at the left hand side they are all SMTP world, but at the right hand side when you receive your email, you don't use SMTP because SMTP is a pull. Sorry, it's a push protocol. So it push mail to the right hand side, push mail to the right hand side. But for your user agent, they have to receive the information. They have to receive the message right when your user agent is online. When you do pull, you have to guarantee that your receiver is online. But as I mentioned before, your user agent may not be online. You may turn off your PC, you may turn off your cell phone. So if the receiver's email server try to push the email, but the user agent is not online, then the mail will not be delivered. So we have some other protocol, which is IMAP. We will not talk about IMAP protocol, but it's very similar to SMTP, but it is another protocol, IFC 3501. Okay, the user agent will implement IMAP protocol in its program and try to retrieve the information from the mailbox. So it is pull, that is push. IMAP. Of course, there are certain mail protocols, for example, such like that POP. But of course, in early days, people use POP protocol or IMAP protocol to retrieve email messages. But currently, we don't use those those protocols quite often because we have some other protocol that can help us to retrieve the emails at the receiver's email server. Okay, we will draw a figure how current email mechanisms, email architectures works next hour. Okay, we will show you how real servers are constructed. Okay, and what kind of different protocols they have to interact with each other, and we'll show you real email. Okay, how to read real email messages. Okay, let's stop right here and let's come back next hour.